Hey everyone, Walter Haydock here. Welcome back to the Deploy Securely podcast, where I go deep on cyber risk management for AI systems. So, cyber risk management for AI is already kind of a confused mess. Should we treat generative AI tools differently than other parts of the software supply chain processing sensitive data? My answer is yes when it comes to unintended training, but no otherwise. How do you evaluate CVEs in AI infrastructure or compare them to undesired outputs of models themselves? My answer would be use the Deploy Securely Risk Assessment Model, DSRAM, for the first, and the Artificial Intelligence Risk Scoring System, AIRSS, for the second. And I'm going to be talking about the AIRSS in this episode. And this lack of clarity contributed to me wanting to develop that system. So I'm going to continue building it out in this episode and talk about how to manage AI model risk using it. If you missed it, please check out part 1 in the series because that's an important primer. Because the AIRSS has many carve-outs for things that it does not apply to, it's important to have a clear way for identifying what it does cover. Bottom line is the AIRSS applies to AI models only. There's already a vast array of proprietary and open source options that have proliferated, so ensuring everyone is talking about the same one unfortunately becomes quite challenging. Applying the existing Common Platform Enumeration (CPE) system probably won't do, but I think the package URL or pURL approach does have some merit. The pURL standard already allows for identification of models stored in repositories like Hugging Face or GitHub, and it can be adapted for broader use cases. For example, I fine-tuned an instance of GPT 3.5 using some stack-aware data, and the resulting model can be represented as a pURL, which I'll put into the notes for the show. The standard way of describing models will become important when we evaluate vulnerabilities in them. And most importantly, when we communicate about them using the Cyclone DX software bill of material, or SBOM, formats, vulnerability, exploitability, exchange, VEX, capability, you'll see that you can describe an entire AI application and any vulnerabilities in it, both traditional and AI specific, using the Cyclone DX approach. So before we get into that, I want to talk about how general adherence to security requirements is more important than individual violations. So now that we're clear about what we are evaluating, we can talk about how to evaluate it. Identifying discrete vulnerabilities is useful only to the extent that it allows us to fix them in a model. While in traditional information systems, patching a vulnerability for a security reason can potentially impact data integrity or availability, this is a relatively rare, although occasionally severe, occurrence. With AI systems, however, this appears to be quite different. There's substantial speculation that OpenAI's introduction of successive safety layers has led to clear performance degradations in GPT-4 and other models. This makes sense, as attempting surgery to fix specific issues or a set thereof is likely to have unintended consequences for the broader model's performance. Combined with the generally non-deterministic outputs of AI models, identifying specific vulnerabilities in a given one is less important than ensuring that on the whole, the model meets its security requirements. Thus, the AIRSS does not attempt to describe individual vulnerabilities, but rather the overall cumulative impact of them on an AI model. From a risk management perspective, the latter is much more important. Because in the end, what we care about is the likelihood of a model behaving differently than intended, multiplied by the severity of this occurring. To talk about these situations with any precision, though, we first need to define business and security requirements. But before we do that, we're going to pause for a quick word from our sponsor, StackAware. As you might know, I really enjoy discussing AI-related cybersecurity, compliance, and privacy risks, and I'm now helping organizations identify and mitigate these types of things. So if you're interested in setting up an assessment, please head to stackaware.com. You can get all the details on how this process works, what the prerequisites are, what the outputs are of this assessment. And you'll also be able to see case studies from organizations like Cobalt Robotics, Reputation, and Encore, who have all improved their AI security posture after a StackAware risk assessment. So if you're interested, please head to stackaware.com to get all the details there and set up a call. All right, back to the show. A first step that you should do before attempting to evaluate the risk of an AI model is establishing the business requirements of that model. Before a developer started putting keys to keyboard, hopefully a product manager somewhere drafted a set of business requirements explaining exactly what a given AI model should do. If you haven't documented what actions software must be capable of performing, it's hard to tell what's a bug and what's a feature. And this is critical for security, especially when it comes to data integrity considerations. For example, if an LLM is passing certain types of information to a function call, it'll need to meet certain types of requirements. For example, it needs to be an integer, it cannot be longer than a certain number of characters, etc., etc. Only if you've defined these things can you know when the model is performing not as intended. Similarly, these requirements will tell you whether and how badly your model's data has been poisoned if, unfortunately, that's happened. Although I wouldn't recommend using the output of a large language model to determine which bank account to wire money to, let's assume you're doing so for argument's sake. And in this situation, I'll lay out exactly what the impacts could be of a poison data set. So in this specific case, if there's a refund processing LLM, then it would probably make sense that the model would kick off some sort of workflow sending money back to the customer's account under certain conditions. If this is a purchase processing LLM, though, that wouldn't make any sense. You wouldn't want to send money back to a given customer's account. So if the model started directing money to customer accounts after they buy from you, then your business would have a serious problem because instead of making money on every purchase, you would be losing money on every purchase. But you can't really say that one outcome is wrong and another correct without defining the business requirements, because if you had a refund processing LLM, it would be correctly functioning if it were sending money back to your customers. All right, next up is establish security requirements. Similarly, before you can determine what is and is not a vulnerability, we need to understand what a model should and should not do from a security perspective. In a sense, security requirements are just business requirements, and there's no real need to distinguish them rigidly. Business requirements usually focus on data integrity and availability, while security requirements often focus on confidentiality, but these aren't written in stone. Additionally, business requirements are often stated in the affirmative, for example, the model shall or the application shall, and security requirements are often stated in the negative, for example, the model shall not or the application shall not. But these aren't mutually exclusive, and these are really just to help with mental bucketing. So to make this more concrete, I'll get into an example of how to explain security requirements. So if you're operating a model using a provider that has signed a Health Insurance Portability and Accountability Act, HIPAA, Business Associate Agreement, also called a BAA, with your organization, and you control access to only medical professionals with a need to know, and there's a valid medical purpose for all the queries against the model, it is conceivable that returning protected health information from this model would not represent a security policy violation. Conversely, in most cases, you probably wouldn't want the model to do this. So it's important that you have these clearly in your mind before you start assigning risk to models. Some additional examples of security requirements might include those that demand a model not return any information about anyone who is not the user, associate any personal identifiers with a given medical diagnosis, name or provide any information about a sensitive business process, or similar things of that nature. All right, so that wraps up this episode. And now we have in place both the scope and a general framework for evaluating risk in terms of business and security requirements. And in the next installments, we'll go through examples of how to calculate AI model risk quantitatively. And then in the final episode, which will only be in written format, we'll look at how to communicate this in a standardized format. So really appreciate you listening, and please like, comment, and subscribe to get future episodes of the Deploy Securely podcast. Thanks for listening.